What problem does the WILDCHAT dataset aim to solve in the field of conversational agents research?
The WILDCHAT dataset aims to solve the problem of limited accessibility to real-world, multi-turn, and multilingual user chatbot interaction data for researchers in the field of conversational agents research. By providing a comprehensive dataset consisting of 1 million timestamped conversations with over 2.5 million interaction turns, WILDCHAT bridges the gap between existing expert-curated datasets and proprietary natural use case datasets. It offers a closer approximation to real-world interactions, enriched with demographic details such as state, country, and hashed IP addresses, enabling more fine-grained behavioral analysis. Additionally, WILDCHAT highlights the urgent area of intervention in toxic chatbot interactions, with over 10% of interactions exhibiting toxicity, providing a rich resource for studying and combating toxic behaviors. Furthermore, the dataset demonstrates its effectiveness for instruction, tuning chatbots, showing the potential to be further curated to create better instruction tuning datasets.
How does the data collection process for the WILDCHAT dataset contribute to bridging the gap in existing user-chatbot interaction datasets?
The data collection process for the WILDCHAT dataset contributes to bridging the gap in existing user-chatbot interaction datasets by providing a comprehensive multi-turn, multilingual dataset consisting of 1 million timestamped conversations encompassing over 2.5 million interaction turns collected via a chatbot service powered by the ChatGPT and GPT-4 APIs. This dataset includes demographic details such as state, country, and hashed IP addresses, alongside request headers, enabling detailed behavioral analysis over time and across different regions. The explicit user consent mechanism implemented ensures ethical data collection practices. The dataset offers a closer approximation to real-world, multi-turn, and multilingual user chatbot interactions, addressing the limitations of existing datasets that are often proprietary, limited to single-turn conversations, and differ in distribution from real-world interactions. Additionally, the dataset reveals a high level of toxicity in over 10% of interactions, highlighting an urgent area for intervention and providing a rich resource for studying and combating toxic chatbot interactions. The effectiveness of the dataset for instruction, tuning chatbots is demonstrated, showing its potential to be further curated to create better instruction tuning datasets.
Can you explain the methodology used to collect the WILDCHAT dataset step by step?
The methodology used to collect the WILDCHAT dataset involved several key steps. 1. Deployment of chatbot services. 2 chatbot services were deployed, one powered by the GPT-3.5 Turbo API and the other by the GPT-4 API. These services were hosted on Hugging Face spaces and made publicly accessible. 2. Data collection. Chat transcripts were collected along with IP addresses and request headers, which included information about browser versions and accepted languages. Users were not required to create an account to use the services, ensuring anonymity and ease of access. 3. User consent mechanism. A user consent mechanism was implemented where users had to agree to a user consent for data collection, use, and sharing agreement before accessing the chat interface. This outlined the terms of data collection, usage, and sharing. 4. Data preprocessing. The back end of the chatbot service operated on a turn-based system, where each turn comprised a user's request and the chatbot's response. A total of 2,713,695 turns were accumulated and linked into 1,054,528 full conversations based on historical conversation content, IP addresses, and request headers. 5. Anonymization of personally identifiable information, P. To prioritize user privacy, personally identifiable information, P. was anonymized using tools like Microsoft's Presidio for P identification and removal across various data types and languages. IP addresses were hashed before release to further protect privacy. 6. Dataset analysis. Basic statistics of the WILDCHAT dataset were presented, showcasing features such as language diversity, user prompts, and toxicity phenomena. A comparative analysis with other conversation datasets was also conducted to highlight the unique aspects of WILDCHAT. 7. Toxicity analysis. Unsafe interactions in WILDCHAT were analyzed using toxicity classification tools, with findings indicating the prevalence of toxic content in user and chatbot turns. The toxicity rate was analyzed over time, and jailbreaking behaviors were also examined. 8. Instruction following. The dataset was leveraged for instruction tuning by fine-tuning a Llama 2.7b model to produce a new model called WILDCHAT. The training details and evaluation results of WILDLLAMA were provided, showcasing its performance compared to other models. 9. User demographics and ethical considerations. Considerations regarding user demographics, toxicity selection bias, the usefulness of more data, and ethical considerations were discussed to provide a comprehensive understanding of the dataset collection process. 10. Continued data collection. The data collection efforts were ongoing, with plans to update the dataset with new conversations as they were collected, ensuring the dataset's relevance and timeliness.
What are the theoretical and practical benefits of fine-tuning a language model on the raw WILDCHAT dataset for instruction, tuning chatbots?
Fine-tuning a language model on the raw WILDCHAT dataset for instruction, tuning chatbots offers both theoretical and practical benefits. The theoretical benefits include aligning chatbot responses more closely with human preferences by leveraging real-world, multi-turn, and multilingual user-chatbot interactions present in the dataset. This process enables the creation of more robust and contextually appropriate chatbot responses, enhancing the overall user experience. Practically, fine-tuning on WILDCHAT can lead to the development of stronger chatbots without the need for extensive manual curation of instruction tuning datasets. The dataset's diverse user prompts, wide range of languages, and detailed demographic information allow for a more nuanced understanding of user behavior and preferences, resulting in chatbots that are better tailored to meet user needs. Additionally, the dataset's high level of toxicity, over 10% of interactions, presents an opportunity for intervention and improvement in chatbot responses, making it a valuable resource for studying and combating toxic interactions. Overall, fine-tuning on the raw WILDCHAT dataset streamlines the process of creating effective instruction, tuning datasets, enhances chatbot performance by aligning responses with user expectations, and provides insights into user behavior and preferences that can inform the development of more user-centric conversational agents.
What were the specific results and outcomes achieved with the WILDLLAMA model in the evaluation conducted using LLM Judge?
The specific results and outcomes achieved with the WILDLLAMA model in the evaluation conducted using LLM Judge showed that WILDLLAMA outperformed other open-source models of the same size, although it significantly underperformed proprietary models GPT-3, 5, and GPT-4. In the evaluation, WILDCHAT excelled in roleplay and coding, but was less effective in responding to extraction prompts. When compared against Llama 2 Chat, WILDCHAT and Vicuña both showed lower win rates, with WILDCHAT slightly outperforming Vicuña. It is important to note that neither WILDLLAMA nor Vicuña included the RLHF step, unlike Llama 2 Chat, which may account for their performance disparity. In direct comparisons between WILDLLAMA and Vicuña, WILDLLAMA was found to lose to Vicuña only 20% of the time, outperforming or performing on par with vicuña in most cases.
What limitations or potential biases are mentioned in the paper regarding the user demographics and toxicity selection bias in the WILDCHAT dataset?
The paper mentions potential biases in user demographics and toxicity selection bias in the WILDCHAT dataset. Regarding user demographics, the paper acknowledges that since the chatbot is hosted on Hugging Face spaces, the majority of users are likely associated with the IT community. This demographic skew may influence the types of conversations present in the dataset, such as an overrepresentation of coding-related questions. Additionally, the paper notes that the URL to the chat service has been shared across various subreddits, potentially leading to an overrepresentation of users from those specific communities. In terms of toxicity selection bias, the paper highlights that the anonymity provided by the chatbot may attract users who prefer to engage in discourse they would avoid on platforms that require registration. This anonymity could result in a selection bias towards more toxic content, as seen in discussions on platforms like Hacker News, where anonymity sometimes correlates with an increase in such content. The paper emphasizes the importance of considering these biases when interpreting the toxicity levels in the dataset, and underscores the need for caution in generalizing findings to broader populations beyond the specific user demographics and behaviors captured in the WILDCHAT dataset.